Hey guys, welcome. So today we're going to introduce a new tool called Laforge. It's actually a tool we've been using for a while, but we think it's ready for public release. So here we go. Quick agenda. We're going to go over kind of why we got here, who we are, and why we're even in this problem space. Then we're going to attack the problem, why is this so hard to do? And after that, we're going to introduce the solution, which is Laforge, this new tool for doing competitive security competition environments. And then we're going to talk about the future and what's still to be done with this tool and how you guys can all help and join. So to begin, we have Alex. Alex is a senior engineer at Uber. He builds a lot of systems. He does detection systems. He does intelligence work. He runs the gambit. And Uber was a big sponsor of all these competitions we're going to talk about and even building these tools. And then I'm a senior red teamer. I do a lot of ops and then also tool dev. And we both work heavily in these security competitions. So security competitions are actually how we met. We met through the USCC, the US Cyber Challenge, which is a great program. There's a bunch of alumni in the crowd and a bunch of people that speak there regularly. And since then, we've just done a ton of security competitions. So we've done CCDC, where we are part of the red team. Alex was actually a blue team there.
Yep.
And then what we're going to talk about today is we got really heavily involved in a competition called CPTC, the Collegiate Penetration Testing Competition. So what is CPTC? CPTC is a competition that started about 4 years ago at RIT in New York, and it was put together by originally Bill Stackpole and a bunch of other people that were really passionate about security competitions. They'd been playing CCDC for a while. So what we're trying to do, if you're familiar with CCDC, that's the Collegiate Cyber Defense Program, where the students have to defend the networks. We're turning it on its head. We're building an entire environment, an entire corporation, and we're allowing the students to attack this corporation. We set up logging, we set up infrastructure, we run it as a legitimate company, and throughout the entire thing, basically the students run a legitimate pen test. So they'll come in, they have to do an RFP, they have to submit, they have to do all the papers to get into the pen test, then they win the pen test. They have an external phase, which are our regionals, and then they move to the internal, where they do internal pen testing, and it ends with a report and a presentation. So it's very real world. We're trying to emulate real world pen testing, and we're trying to get students involved in it. Because as much as you do this stuff in college, once you get into the real world, you're hacking boxes, and you have to stand up in front of, potentially the C-level or the security team and present your findings. And we think that that experience isn't really gained in college. So we are big proponents of these competitions that give people this experience. So this is a model of the infrastructure. You can see we put a lot of work into this. There's multiple networks, there's multiple hosts, and what you don't see here is this is one team. We actually scale this by as many teams that compete. Last year we had 16 teams in the regionals, and then we had 10 teams at the national competition.
23 at regional.
Okay, 23 in the regionals, and then 10 for the nationals. So it was this infrastructure times 10. So you can see we have a really big problem. We have to set up all these hosts and then manage them.
You also don't see in this diagram all the jump boxes and all of the team's infrastructure. So this is just the competition network. There's actually about double this when you take into account the jump boxes. Every member of the team has a Windows and a Kali Linux instance running in the cloud as well.
Yeah, the VDIs are how they hit their environment. So it's all segmented and compartmentalized too. So they can't leak out of their environment and hack the school or whatever.
Last year's regional was 1,471 hosts.
And another thing, I don't know if you can see it in this diagram, is but we actually do it cross providers. So we'll do it in multiple clouds and across different providers for resiliency. So this is a lot of infra, and it sucks. Pretty much, this is a big problem. And we've had a lot of developers, and all the developers approach it from their own perspective. So we needed a tool to kind of unify everybody and bring everybody together so we could write this stuff. And the tool needs to be simple. It needs to be an easy language to write. This is the first language people are going to be writing, so they can't be learning something new. It needs to scale, but it also needs to work across multiple providers. So we couldn't just use something like a traditional DevOps tool like Terraform. We had to kind of come up with our own solution. And like I was saying, we want resiliency, so we don't want to just stick to one cloud provider. We want to have multiple cloud providers in case one goes down. So the solution, Laforge.
Yeah, so you guys like this slide? And this is I ran into a nice little slew of Jordy and Data online little anime caricatures, and so I just had to throw that in there. Yeah, Dan did a great job kind of covering why we why we needed to go out and build our own tool, right? This isn't a talk about us hating on traditional DevOps tools like Terraform and Ansible. They're really good tools, right? Like the people that made Terraform are brilliant people, but they made it for a use case that just wasn't ours. We took a lot of inspiration from them. We took a lot of inspiration from a lot of these other DevOps and operations companies. You'd be surprised, us being security people, how little we actually know about that space. It's a whole industry that really operates just, almost like ours does, right? There's DevOps conferences, there's people that go around and talk at conferences about this stuff, but it's a science to them just like it is to us, and we really don't take the time necessarily to go out and learn it. So part of this on our side was going out and actually trying to understand the current space of DevOps and realize where we needed to be and what effort we needed to put in on it. So, we're going to build all of this competition infrastructure. Well, you saw how big it was. Am I going to just have a hard drive with OVAs on that? That's not going to work in today's age. We need to have our infrastructure as code. We need to have it reproducible. We need to be able to say, I'm going to go build these 5 hosts, and then I'm going to hand them to Dan, and Dan's going to press a button, and he's going to get the same 5 hosts that I just built.
And I can add one thing, ship them back,
exactly.
And we can, merge and redeploy a test M.
Exactly, and that was something we saw as security people. Is we're not developers, we're not DevOps experts. So for us, a DevOps person might find Terraform really easy. We wouldn't, right? They're just not tools we're used to. So for us to be able to have a group of people building this infrastructure, we really had to just go out of our way to try and make it easy for them.
Yeah, most of our team is volunteers. They're doing this on a weekend. They have a month to kind of help us put together this infrastructure. So
right, and so let's kind of talk about the history of Laforge here for a bit. So the very first version of it was this really embarrassingly large Ruby script that I wrote that just, I was writing Terraform configs for CPTC, and I got really sick of writing the same 25 lines over and over and over again. And I was like, I can just template this out with Ruby and make it happen. And then as we scaled the competition out, all of a sudden, to generate my Terraform templates, it was taking literally 10 minutes. So we went out and said, okay, let's how can we solve this problem? It was about the same time. For those of you, I see a lot of CCDC people in the room. I love you guys. This is not a talk where I'm going to talk about how I hack you. But we were getting into Go for those reasons.
Yep.
And we decided, let's see, maybe we can rewrite Laforge in Go. So we took a stab at it. It went really well, I would say. It's kind of supported us in that V2 version for the last 2 years.
It was really fast.
Yeah.
We could iterate on. We could ship a single binary. Anybody could use this single binary. So it was nice. It was like redeployable.
It really was. The biggest problem with Laforge V2, honestly, 10 minutes. Thank you. The biggest problem with V2 Laforge in my mind was that I just didn't understand my users enough. I needed time to put something in front of them that they said, this sucks. Can you fix this? So after another year of us just watching how people used V2, this past spring, we decided, you know what? Let's throw that one out. Let's do it all over again. Some of the big problems we had, and we'll kind of talk about it. They don't really talk about it on that. It's fine. Some of our problems were really around how we decided to make the structure, right? So when you used Laforge last year, you had to clone a repo. You had to set up some .files in your home directory. You had to set some environment variables. And you had to go and you had to know where everything was in this folder structure. And if you didn't know where something was, you might have messed something up, then it would just break something for a lot of people. And then you'd be like, oh, what have I done, right?
Git pull.
Yeah, and that really was a difficult experience for us. It showed me that a lot of the problems with Laforge V2 that we needed to solve in V3 were really around usability. It's really fast at generating these configs. It has a lot of extensible uses, but it's just not, people aren't finding it fun and easy to use. So what we did this year is I sat down and I said, okay, what are the tools people really do like using that they use every day to collaborate with code with other people on, right? And the 2 tools I landed on were Git. How many people in here do a Git command at some point in their week? Yeah.
Awesome.
Does everybody find that just easy? Yeah. One of the things I really loved about Git is you could be anywhere in a directory, and Git knows that you're still in the Git repository, even if you're 5 folders deep in that, right? That's the kind of just implicit awareness that I wanted this software to have. The other tool that I took a lot of inspiration from on this was Docker. I'm not a Docker expert by any means, but as I've started to play with it the last couple of years, I've noticed that they do this sort of layered approach to how they build these containers up, and I think that's a really interesting thing. You don't have to rebuild everything every time, right? Compilers have been doing this for years, caching objects and whatnot. So figuring out a way where we can take the best of both of those worlds, where the nature of it is just implicit. You don't have to go and explicitly say things, and the actual tool itself doesn't just have to constantly just do its state over again every time you build. So we got rid of YAML, because YAML, if anybody's ever used YAML in a distributed environment where somebody has Windows, another person has Mac, yeah, I see Doug is over there just shaking his head, right? You get one person with Windows line endings, and you're done. The whole thing doesn't parse. So we got rid of YAML, and we were like, oh, that'll solve our problems, right? It didn't, because we still hadn't solved the underlying issue, which was we needed to make it easy for people to use. So,
give an example of what that looks like.
Yeah. So this is kind of the structure of the old YAML here, where you had all these folders and you had all these YAML files. And again, is this easier than writing a Terraform config? Absolutely. Do you need to learn Terraform? No. You just need to read the comments in our YAML, and you can probably just, really just figure it out. But
just set up some network, set up some hosts, run some scripts.
Exactly. So what we've done in V3 with Laforge, and we're running out of time, so I'm going to be real fast with this. We basically made Laforge contextually aware, just like Git is aware when you're somewhere deeper in a folder structure. Git knows that you're there. Laforge knows implicitly where you are, and depending on where you are, knows how to load the dependency graph for that environment. Now, what do I mean by that, right? We talk about those Docker layers. This is exactly that concept here, where every time you go to a different location within the folder structure, Laforge really just knows where you are and can overlay the configs on top of the dependence of the environment that you're in, right? So this is a little screenshot of Laforge now, where I can just run a command, Laforge Debs, in any of the directories inside of our info repo. 5 minutes, thank you. And it'll show me, okay, so my main is the build right there, the build context, and that's just inheriting down from those, right? And what's nice about this, here's another command, Laforge status, shows you at any point in your repo, just like git status, what your current context is. Here's kind of an example of why this is really powerful in this situation. So we have our own little config language called Laforge. The files are .laforge files. It looks a lot like HashiCorp config language. We use some of their parsers and ASCs to implement this. So you have a host config, which is just this block with an ID and some variables there, right? And that's in a global context. Over here in your env context, which is yours, this is shared, this is yours, you decide you want to just make a change to host ext1. So you make a change. Well, in new Laforge, this just inherits this way, and you just patch over the top of it. You didn't have to rewrite his config. You didn't have to go in and figure out what needed to be changed or what didn't need to be changed. You just said that for my environment, host ext1 needs to just be slightly different in this particular way. And that's what makes new Laforge so powerful, is no longer are you just having to drop hundreds of YAML scripts in a folder and hope everything works. Effectively, right there, it shows you now in my environment, that's what ext1 equals. It's non-destructive, so anybody, if Dan has in his environment, if he's extending ext1, he doesn't see any of those changes.
And we can even say how they conflict and
Right.
what happens when that happens.
So another pragma that's inside of the new Laforge configuration language is an onConflict block. You can actually describe, if you are going to collide with an object, how you want that to be handled. So in the previous example, it was just going to do a soft merge between the two. In this configuration, it's just not going to accept any of his configs and say, no, the only thing is valid is mine in that state, as bare as it may be. So how does this happen? How does this know what it needs to be loading? That's a hard thing to cover in 90 seconds, but we'll give it a shot. Graph theory in 90 seconds, great, yeah. So I took a lot of this stuff in school, and I'll be honest, I'm pretty sure I got C's and D's in it, but tried my damnedest. And
Here we are.
I think I learned something here. So the whole concept of like Dijkstra's algorithm and switching and cost of paths and stuff like that, it's fascinating to me, especially when you start looking at dependency graphs of software. So when you have files that include other files, at what point do those things get loaded in? And that's exactly where kind of the magic behind new Laforge, right? So we have A, imagine that like our env context configuration. That's going to load B and C is going to load D and E, and D it's going to also load F, right? So if you think like 6 degrees to 6 degrees to Kevin Bacon, right? Like there's a stage that you can count incrementally on how far away from the center that you're getting with these. And that's exactly what Laforge does, is when you go and anytime you're in your repo, when you do a git status, a Laforge Debs, it walks your entire dependency chain contextualized to the directory that you're in, and starts at the first, and just like Docker, just starts building up the layers of the config, one on top of the other, applying the differences, using the on-conflict pragmas to make sure that everything is keeping sane, right? Like this is actually what you end up with, right? Layer 1 gets layered on by layer 2, layer 3, and that kind of stuff. So your environment no longer has to be a bunch of duplicate code of Dan's. I can actually just extend Dan's environment in particular ways and have everything that Dan just
overlay
did.
It.
And now I can just work on it at my leisure. So there's a new preview of it. It's live. Be gentle. It's alpha preview V00 pre-beta, whatever you want to call it.
Still in flux. You can help us.
It does work. It's there. If we want to step outside afterwards, I'll give people a little demo of it. It's really, you know what? Oh, I'm on your laptop. Can't give the demo. It's fine.
Yeah, we're done.
Yeah, so you can go check it out. The code's there. It's in Go. If anybody here is a gopher, please hop into it. It's kind of fun and wacky. TLDR of it, we can build competitions super fast. I think CPTC last year probably had more infrastructure than almost any collegiate competition I've seen in a long time. We did it with a very small staff of people, and it's not because we're really good. We just automated ourselves into looking so good.
Yeah. And it scales per team, so you stand up one environment,
right.
You get 10 copies. It's great for competitions.
That is the original thing with Laforge, is I didn't want to have to write for 10 teams the same config 10 times. I just wanted something to build me 10 configs. And now Laforge does that with a bunch of bells and whistles that make me not look like a failure in math class, I guess. And coming in on time. Woo!
Right on time.
Thank you.
Thank you. A big round of applause. If you have any further questions, since there's no one here, you're welcome to stay here and ask questions, but the streaming will be ending in a few minutes. In 5 minutes. Great.
Okay, cool.
Any questions?
Questions? Yes.
So the question was, what are some of the things you can do in the config?
Can you give a real-world example of something that you can deploy through this and how the deploying works?
Yes,
Yeah.
I can.
Just like a single host.
Great question.
Great question. I can zoom in on this. Okay, so this was our dev environment for Gotham elections. There are hosts that have dependencies here. So for example, DCO2 needs to DC promo before backups01 joins to that domain. There are DNS records in the GitLab box because the GitLab box deploys code into the production environment, right? We don't build these competitions to just stand up some Metasploitable box. We build real integrated applications,
like
right?
debug is going to be catching logs from all these other services.
Exactly. And so I asked myself, like, I don't know how to use Salt or any of this stuff. Like, how do I deploy this stuff? Well, I know how to write shell scripts.
Everybody knows how to write shell scripts.
So we probably could have done a better job covering that. With Laforge, to actually do the configuration, like, yeah, you do your Laforge, little markup statements and whatnot. There's a section there where you just define scripts. And those scripts are just shell scripts or PowerShell or whatever you want. You can define Python scripts, and if there's a Python interpreter, it'll try and push it in there.
So in the new version, we can actually put dependencies on the scripts. So we could say, stand this up as infrastructure, run these scripts, but then wait on these ones until those are done. Yeah,
but at the end of the day,
very nice.
But at the end of the day, configuring GitLab doesn't require me learning Salt. I just have to write a shell script that knows how to take Ubuntu 16.04 and builds GitLab out.
Which is great for volunteers because, again, everybody writes shell scripts. They give it to you. It just configs the thing.
One of the powerful things about it that I saw last year was for the first time we were able to solicit volunteers to help contribute to this. So Koss actually was a prime example of this. Came in 3 days before the competition, said, I want to help. How can I help in any way? We're sweating. We're just like, don't talk to me right now. But then it hit me. It's like, he doesn't need to learn this. Kyle, go write me shell scripts that like do cool and interesting security things. That's it.
Shell.
Yeah, and just make them small and give me like 7 different ones so that I can just kind of scatter security things around this infrastructure. And then when I go back to score, I do scoring at CPTC, I just go through the shell scripts. Because right there, I can be like, oh yeah, he put a vulnerability there. Like I just audit the config and boom. I have my rubric for how we're going to score that year's competition. It was really powerful. We had probably a half dozen people last year at CPTC contribute scripts without having any knowledge of the environment, how Laforge worked, or anything.
It also lets you design the environment and the networks and the configs and then kind of push that downstream and other people just stand up and config the boxes.
Exactly. Yes?
So there should be any pre-built sample environments out there you can start with it and build from there?
So the question was, are there any pre-built sample environments or environments you can just get up and running with real quick right now?
So there would have been had we have just said, yeah, we'll just release V2. V2 code is out there, but the V2 configs are not. As I'm going through, like I was up last night writing the README on GitHub. I'm going to be putting up examples and stuff like that on there. Part of my new development methodology with this is to actually just start writing an entire specification to test against, and that spec itself will be an example environment. There's also a subcommand if you want to know like how do I configure this. You just run Laforge example script or host, right? You saw the little host block. Laforge example host will literally print a host block with all the parameters. Then you can choose which ones to fill in and want. Just copy that into a text file, and it's there.
The one issue is you do need a provider, so you need like AWS or like keys like that, right?
You don't need it to play with the model.
Okay.
So you can build all of those relations and dependencies.
You can't spin them up
without actually spinning up something in AWS, right? You can play with the language, you can play with the configs, you can play with inheritance and layering stuff on top of it. We've developed, now we just have to develop the plugins itself. Laforge is now it's going to compile to Terraform or it's going to compile to Vagrant. That's all now extended out into a plugin system. So I'm actually writing the Terraform one right now. We've got a null one. I'm going to do a native one that just spits out a shell script. It's a lot easier. The old Laforge, you wouldn't have been able to say, yeah, let me just write one for Vagrant. Like that's not going to happen. But the new one totally will. And if you don't like Terraform or Vagrant and you want to use something else, let us know what that is. And if it's easy to do, I'd love to make a little plugin for it.
Thank you, Alex and Dan. For any other questions, please go outside and have a wonderful lunch.